This video is going to look at how we use the law of cosines to help us out when we have problems that we can't solve using law of sines. So let's review kind of what we talked about from the last couple videos. What information in a triangle for law of sines needs to be given to know that you could possibly have two solutions? Well, we know that it was one of their situations that was not possible to prove a triangle congruent, and that was side-side angle. What information in a triangle for law of sines needs to be given to know that there would be exactly one solution? In other words, we don't have to check to see that there's a second triangle solution. Well, we know that that was one when we had two angles and a side, whether it be the side adjacent to one of them or the side between them. The key thing was the fact that we had two angles, therefore we had to find the third angle was unique, and therefore it didn't matter which side we had, as long as we had a side opposite one of our angles. So, what do we want to do for law of cosines? Well, law of cosines really helps us determine kind of, well, what do we do if we can't solve it using law of sines? So let's talk about the law of cosines. So what if we were only given three sides, or even two sides, and the angle between them? Well, in order to help us think about this, we're going to draw a right triangle to help us think about this. So here's our triangle, and we've drawn in the altitude here, we're calling it y. And I've labeled a couple pieces here that we're going to kind of refer to just so we can kind of see them. I've got this little piece over here, this is part of my base C, and that's labeled at x. And then this height, like I said, the altitude here being y. So that way you can kind of refer to this little right triangle in terms of kind of the piece of side C that we have. So would you agree that based on this right triangle I've drawn in here, that the cosine of angle A is going to be equal to x over b? And would you also agree that the sine of angle A would be this little section y over b? So therefore, if I was to solve for x, x would be equal to b times cosine of A, and y would be equal to b times sine of A. So if we use the Pythagorean theorem and what we just talked about, we could say the following: that if I take this piece of the triangle, and this piece of the triangle, and this piece of the triangle, it would form a right triangle, and we could use the Pythagorean theorem to write the following: that a squared, our hypotenuse, equals our quantity of c minus x squared plus y squared. And knowing what we talked about before, we could plug in that b times cosine of a was equal to x, and b times sine of a would be equal to y. So if I put this together and simplify it just a little bit further, we can think about what we would do. Well, first thing I'd probably do is square out the quantities. So we'd have a squared equals c squared minus 2cb cosine a plus b squared cosine squared a plus b squared sine squared a. You can see something special going on over here, don't you? If we factor out a b squared, we should have an identity. And in fact, we do. We have cosine squared a plus sine squared a. We know that's 1. Great, that's one less thing we need to worry about. So then, rearranging just a little bit more, we get part of what we have for our law of cosines, and that is that a squared equals b squared plus c squared minus 2bc times the cosine of a. So if we know all three sides of the triangle, we could find angle A just by using our formula. We see that angle A is over here. Now, this doesn't look great. I mean, we can use it, but it's not necessarily straightforward. But the law of cosines helps us whenever we know any three given sides, we can find any given angle. So your formula sheet looks like this. One for solving for A and sine of A, or cosine of A, excuse me. One for B with cosine of B, and one with C and cosine of C. So if you wanted to find a missing side, it'd be great because it's set up for A squared, B squared, and C squared. But it's not so great set up to find an angle. So you'll notice that your cheat sheets have an alternative form. So obviously if a squared equals b squared plus c squared minus 2bc cosine of a, I could solve for cosine of a and get this. In the same respect, if I look at the one solved for b squared, I could get this. And of course c squared, I could solve for this. Note that these are not new equations, they're just solved in another form. So if I wanted to find a missing angle, I'd probably use the alternate form. And if I wanted to find a missing side, I'd use the first form. Note that both of those are given to you on your cheat sheet. So what were the limits of the law of sines? Well, did you notice that the law of sines never gave us an obtuse angle as an answer? Wonder why that was. Well, we know that if we had an obtuse angle, the only way we found that was if we assumed that there were two solutions. There's a reason for that. So when we use the law of cosines, we want to find the largest angle first. How do we figure out which one's the largest angle? Well, from geometry, we know that the largest angle is always opposite the largest side. So let's look at an example that starts problem solving using law of cosines with all three sides. By the way, have you figured out why the law of sines never gave us an obtuse angle? Think about the quadrant it's possible in when you're doing inverse sine, and you might figure it out. So, before we actually go too much further into a problem that has all three sides, we want to not forget the triangle inequality theorem. Do you remember what the triangle inequality theorem was? Well, that triangle inequality theorem is really important because this is something we need to check to make sure it's a possible triangle. So let's see if you remember. For example, let's say I give you two sides of a triangle, 2 and 4, and I want to know what are some possible sides of this third, or possible of this third side. We know that the triangle inequality theorem says that if I take any two sides of my triangle, added together, they need to be greater than the third side. So this would tell me, for example, if I added 2 plus 4, I'd get 6. We know that this has to be greater than that third side, so 6 has to be greater than that third side. We also know I could find the other way, looking if I did, 4 minus 2, because if this was the larger side, we know that the other side has to be something greater than 2, but less than 6. So the key thing we need to remember, though, is that whatever sides you have, any two given sides have to be greater than the third side. So the easiest way to check that is looking for the two smallest sides. If the two smallest sides sum together to something that's greater than the third side, you're good to go. So let's look at an example and actually work through this. So we're given the three sides of the triangle. Again, the first thing we should always check is, let's make sure the triangle inequality theorem works. Our two smallest sides are 8 and 14. If I add 8 and 14, is it true that it's greater than 19? And the answer is yes. So this is great. This means there is a triangle. If this didn't work, by the way, your answer would be no solution. And yes, you could plug in the numbers into the formula and get an answer, but it wouldn't be the right answer. And again, we're given three sides, and so we know that side, 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 which tells us we have a unique triangle. So there's no need with law of cosines to ever find two possible triangles, because we're always going to give a situation where we have one unique triangle. So let's lose our law of cosines. Remember, the hint was we always want to find our largest angle first. That's because if we have an obtuse angle, it's going to be the largest one. And the largest angle is going to be opposite the largest side, which in this case is side B. So I want to start by using my angle B in my formula. So we're going to choose the one that says cosine of angle B equals a squared plus c squared minus b squared all over 2ac. And we're going to plug in those values. Obviously, I'll plug this into my calculator. When I plug this into my calculator, I'm going to get an answer. We know in order to figure out what angle B has to be, we're going to have to take inverse cosine of this answer. So we're going to have to do inverse cosine of this answer to give us our answer for angle B. So go ahead and plug that into our calculator and see what we get. That is going to be about negative 0.45 or so. And of course, take the exact answer of that. Don't round that when you're doing it in your calculator. And we get the answer here is that angle B is going to be approximately 116.8 degrees. So we've got angle B. Great. And it is an obtuse angle. Great. This tells us that we're not going to have any more angles that are greater than 90 degrees because we know in a triangle we can only have at most one obtuse angle. So we've got angle B. So now all I need to do is find angles A and C. Now from this point, you really have a lot of different choices. You could either continue using law of cosines to find angle A or angle C, or now that we've found that the obtuse angle, we could actually use law of sines if you want to. So if you want to go ahead and use law of sines because you really liked it so much, then go ahead and use it. So we just found angle B, so let's go ahead and write the law of sines for angle B, and let's say we want to find angle A first. So cross multiply and solve, we find out that angle A is going to be approximately 22.1 degrees. And now that we've got angle A and angle B, finding angle C is simply taking 180 and subtracting the two angles that we have. And that will tell us that our third angle, angle C, is going to be approximately 41.1 degrees. So angle A was 22.1 degrees, angle B, 116.8 degrees, and angle C, 41.1 degrees. So remember, when you're using law of cosines, if you have an obtuse angle, you want to be able to find that first. That's the advantage of law of cosines. Law of cosines finds obtuse angles, law of sines does not. Again, think about when we did inverse cosine and inverse sine, and you'll know why we got, obtuse angles possible for cosine but not for sine. So look for the largest angle first. It doesn't have to be obtuse, but if it's going to be, it's going to be the first angle you find. Then once you find that largest angle, then you can either use law of cosines or law of sines again to find the missing two angles. So here's an angle for you, or triangle for you to try. This time I'm giving you a couple different things. I've given you angle A, side B, and side C. Do you see why you might not be able to, or why you can't use law of sines here? Well, if I think about the fact that angle A is 115 degrees, and side B is 15, and side C is 10, I've got side angle side. And we know that that's not a way that we can use law of sines for, because law of sines says we need an angle and a side opposite it. The one angle we know, we don't have the side opposite. So we have to use law of cosines. We already know angle A is, in this case, the obtuse angle. So we don't have to worry about any other obtuse angles. Angle B and angle C are not going to be obtuse. So it's up to you how you want to proceed. You could go ahead and by finding side A first, or you could find, actually I think that's the best thing we're going to have to do. I don't know that we could do anything else because we don't know angle B or angle C. So I would start by finding side A. So go ahead and see if you can find side A. We can find the missing two angles. And here is the formula that I used to find side A. Remember that once you've got this quantity, don't forget you need to take the square root of this answer in order to get your answer for angle A. So once you've got that, then if you really want to, you can go ahead and use law of sines. Like I said, we've already found the obtuse angle, so we don't need to worry about it. So you could find angle B, say for example, first. And then after that, you could find angle C. And go ahead and try and see what you get for that. I get that angle B is 39.7 degrees and angle C is about 25.3 degrees. Again, depending on what you round, these three angles may or may not add exactly to 180, again, because we're doing the rounding thing. So if you find two angles, go ahead and just use, to find the third angle, go ahead and subtract from 180. That way you'll always add up to 180 degrees. So law of cosines is really helpful for that, especially when we have unique triangles like side, 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 or side angle side. But we can also use it to help us actually figure out area. And I'm not going to go over the proof of how this comes about, but on page 490 in your book, you can kind of see how where you have the three sides of a triangle, you can find the area just by knowing the three sides. The key thing is that you have to use this value S, which we call the semi-perimeter. And S is simply calculated by doing exactly what you would think a semi-perimeter would be. Add all three sides of your triangle, divide it by 2. So every time you see this value of S in your equation, you're going to plug in this value. This will be much easier if I demonstrate by looking at an example. So let's say we just want to find the area of this triangle and nothing else. So we've got sides A, B, and C. We need to find the area. Well, our formula says that we need to find the semi-perimeter first. So we need to find this value S, which is going to be basically adding our three sides together and dividing by 2. So that's going to give me 10.5. Plugging it into my formula, my area says it's going to be the square root of my semi-perimeter, 10.5, times my semi-perimeter minus the first side, times the semi-perimeter minus the second side, times the semi-perimeter minus the third side, and of course this is the square root of this whole thing. So plugging that into my calculator, I get approximately 17.4. So that's the law of cosines and how you can use Heron's formula to find the area given just three sides of a triangle.